Hi everyone, and welcome to ICRA 2026. And I especially welcome you to the first workshop on generalization in autonomous driving, paradigms, practice, and public road demonstrations. In this half day workshop, I and my team invited some very nice speakers that are in the realm of autonomous driving, but with a heavy focus in how can we actually generalize. So today is quite packed. Now we will do some short opening remarks and then we will get started with our first presenter. We then also have a poster and spotlight session. And of course, there is enough time to exchange ideas. But when we talk about autonomous driving in the year 2026, where are we? What have we achieved? I mean, if I'm looking here into the hall of people, I'm probably sure nobody came with an autonomous car today. So if we look at the current state of the art, what we first see is, of course, the USA. I think here number one is to name Waymo. Waymo figured out a level 4 vehicle without safety driver, and they are currently in business in multiple cities like San Francisco, the Bay Area, Los Angeles, or Phoenix, Arizona. And Waymo is actually earning money already. Of course, there's a lot of trips to make in order to get back the money they invested, but Waymo figured it out. And Waymo is scaling slow but steady to other cities. Then we have the first purpose built vehicle. What you see here, the Zoox car, which is a specific built level 4 vehicle that is operating right now in the San Francisco Bay Area and also in Las Vegas. So the USA, I would say there's many companies, they figured out autonomous driving. It's reality, you can drive there. And they figured it out also from a safety level up to level 4. So then we look at China, completely in the opposite direction of the continent. And we see in China, there's multiple companies like Pony AI, Baidu, or VRide. They offer also autonomous level 4 vehicles for the transport of people. So also here in China. The issues with China, we don't actually know how they are doing it, what is the software behind that, and how did they figure out the scale up. So then let's look at German companies, for example. In Germany, we had BMW and Mercedes Benz with level 3 vehicles, but both of these vehicles were discontinued. Right now, when we look at German companies like Volkswagen and Moja, they get their software and like the hardware is, of course, coming from Volkswagen, but the software is completely coming from Mobileye. So Israel as a big developer for software functionalities. And then we have new and emerging players on the market. And one of the biggest ones is for sure Wave, coming from Great Britain. So when we look at all of these, starting from the Waymo, China, Europe, Israel, Great Britain, the question is, how do those vehicles generalize in the future? All of them figured out how to drive. All of them figured out how to be safe. All of them figured out a level 4 functionality, but none of them emerged to new countries, emerged to new markets. They all basically stayed for now in their well known areas, in their well known ODDs. When we talk about generalization, first of all, we talk about the long tail problems. Issues like weather and adversarial setups that bring the autonomous car into difficult situations, especially when we're going out of the ODD. Then, number two, of course, the domain shifts. Going from the sunny California, maybe to a rainy Germany, is something difficult, something a lot of researchers working on, and something we have not figured out 100%. Of course, when Waymo went from Phoenix, Arizona to San Francisco, there was a clear domain shift, but still it's in the same country, same environment, same climate zones. So there is, of course, a domain shift given, but it was a smaller one. The bigger ones occur when you go from one country to another one. And finally, everything is about safety. It doesn't matter if you work with teleoperation in the back, if you work with ISO standard certification, if you self certify, or if you follow some rules and laws like we have in Germany, the law for autonomous driving. So safety is always paramount. So now we need to try to solve these generalization issues, and there's two ways of doing that. The first one is focusing on software development in a classical full software stack from perception, planning to control. We start with this modular software stack and then put the safety around it. In this way, we can scale up slow but steady, but we can make the whole software safe, reliable, and certifiable. This was the setup of how we have done it in the last couple of years. We know since 10 years that end-to-end software stacks like reinforcement learning, behavioral cloning can have a big advantage for autonomous systems because they basically learn how to drive. In the last 10 years, a big issue was safety. How can we certify a black box system? How can a black box system generalize when it was trained in simulation? How do we bridge the sim to real gap? So many questions come all along the way. And there was always the clash between full software modular stack and an end-to-end software stack. Right now, the pendulum shifts towards the end-to-end software stack, as we see, for example, Alpamayo or the company Wave, showing that this is generalizable and scalable, but not 100% certifiable yet. So we need techniques to overcome this issue. So the question is, who will win the AV race at the end? Is it the classical automotive and engineering way? Is it the data-driven way where machine learning techniques and AI-based algorithms have a bigger part, especially with the rise of new methods like the foundation model? Or is it something about the process, for example, an open source way where we democratize autonomous driving, where we share code, and where people all around the world can develop? The answer cannot easily be given, and that's why we are having this workshop, and we want to explore today which way is the way to go. Are we even asking the right questions to the generalization problem, or is there something different we need to look at? And are there other ways that should be considered? So I'm very happy that together with my colleagues Markus Lienkamp from the Institute of Automotive Technology and our PhD students Ilya and Corbinian, we organize the first workshop on generalization in autonomous driving, paradigms, practice, and public road demonstrations. This workshop today is fully packed. We will have multiple speakers, and that would not be possible without strong supporters. First of all, we are saying thank you to the IEEE RAS Technical Committee, Autonomous Ground Vehicles and Intelligent Transportation Systems, the company Tier 4, the AutoWare Foundation, our Munich Institute for Robotics and Machine Learning Intelligence, as well as the Robotics Institute of Germany, who sponsored us for this workshop. We will have 5 speakers today, starting with Hongyan Lee, an assistant professor from the University of Hong Kong, who is an expert in AI for robotics and especially in 3D vision and generalization. Number 2, Cristina Oliveira Monreal from the JKU University of Linz, where she's the head of the Department of Intelligent Transportation System. And she will talk about benchmarks to real-world autonomous driving. We then will hear from Keshav Chitta, who is the co-founder and CTO, Kesai, a new non-profit open science lab for scalable physical AI, where he talks about democratizing autonomous driving. Milan Ganai, a PhD student in Marco Pavone's lab at Stanford, who will talk about embodied reasoning for out-of-distribution reliability. And finally, Felix Fendt, who is a PhD student at the Technical University of Munich, who will talk about open source with as a catalyst for solving the generalization problem and share with us how their team used autonomous driving open source software called Autoware. Thank you very much for joining. Please enjoy the videos, and I'm looking forward to hear back from you. Thank you very much.